Mentioned the ocean is vast, and animals use different signals to communicate, to orient, to find their prey, to figure out where their predators are. If you think about it, light doesn't travel very far underwater. Neither does odor. Neither do most signals. But sound, as it turns out, travels very far and very fast, much faster than it does in air. And so it's no surprise then that this is used as a sensor by many animals in both freshwater and marine systems to communicate, to orient, to find their food. And so soundscape ecology then is the study of those soundscapes and the animals that live within them. I think it's fair to say that most people know that whales and other marine mammals make sounds. It's been known for a long time. But what's much less known is that most fish make sounds as well. And so we have documented now about 1,000 species of fish that make sounds, and there's species-specific sounds. There's a few others that perhaps don't make sounds, but considering that there are about 25,000 fish species, we have a lot more work to do to understand this vast, understudied biodiversity. And one of the reasons why it's been understudied and unexplored is because there was this assumption that the ocean was silent. And one reason for that is that humans don't hear very well underwater, and so they assume nobody else did. But as it turns out, it's not silent. It's a cacophony of sound. And so we are trying to document this diversity. One way we've done that is to put a database together and a website, and it's called fishsounds.net. And it tries to bring together everything we know about fish sounds and all those sounds that have been documented. And so that grows every day as people explore and discover more and more sounds. You could go right down to the harbor right now, put a hydrophone in the water, and discover a new sound, which is amazing, because if that was a bird sound, it would make the news.
Absolutely.
But not if it's a fish sound. So, and the other really important part of this, so biological sounds are not unique underwater. They're not the only part of the soundscape. In addition to biological sounds, we have geological sounds, the geophony as we call it. So the winds, the waves, the rain, the ice, all that makes sounds as well. And that, of course, has been around forever. What hasn't been around forever and has been increasing exponentially are human-made sounds. Wow. And so those are the main sources of those sounds, which we call noise generally, are ships and all sorts of ocean exploration and ocean construction. And so this has opened a whole brand new field of soundscape ecology, trying to understand what the effects of this increasing noise are on marine organisms. And the more we look, the more we realize that those effects are generally negative. And so we're understanding that, we're trying to study it. And it also means that there are particular signals to healthy habitats from a sound perspective. And we can hear that, we can say that's a healthy environment. Whereas we might go to one that isn't as healthy, and from a sound perspective, we can tell that. Yeah. The other reason this work is important is because there are environments, ecosystems, which until very recently were considered pristine. An example is the Arctic Ocean. Ships were not able to traverse the Arctic until very recently, and because of climate change. And so here's an environment where noise did not exist till very, very recently. And so it's a chance to explore what the effects are going to be on the fish populations there and a lot of the marine mammals. So a lot more work to be done.